as a kind of summary of what we saw in this course as well as the earlier course, data structures, the kind of problems we looked at can be called either an optimization problem or a decision problem. So what is an optimization problem? So an optimization problem is something where you want to minimize or maximize a solution. An example is the minimum spanning tree problem that we just did in the graph theory module. So given a graph with edge weights, what we wanted to find there is a spanning tree such that the sum of the edge weights is minimum. So that is like a minimization problem. We want to minimize the sum of the edge weights on a spanning tree, minimum, to find a minimum spanning tree. Similarly, the shortest path problem is also an optimization problem. Given a graph, you want to find the shortest path from one vertex to every other vertex, or all past shortest path. That is an optimization problem. Okay. Now, what is a decision problem? A decision problem is where you want an yes or no answer as your solution. So, in optimization problem, you want to minimize the solution. It means you want a number that is kind of the minimum possible weight for a spanning tree, or the minimum shortest path weight, and so on, or maximum weight spanning tree, or anything minimum or maximum. Whereas in decision problem, you don't want a number as a minimum or maximum value. You want an yes or no answer. An example for this is the bipartite graph problem, or the two colorability problem we saw in the data structures class. As a result of running breadth first search, you should be able to decide whether a given graph is bipartite or not. And if you remember, the rule for that is there should not be cross edge between vertices at the same level. If there's a cross edge, if there's at least one cross edge between vertices at the same level as a result of running breadth first search, then the graph is not too colorable and it's not bipartite. So basically, by running the breadth first search algorithm on a given graph, we were able to decide whether it is too colorable or not. That means it's an yes or no answer. Okay, so such problems are called decision problems. Okay, now we are going to see some more problems in this module called the Hamiltonian circuit problem and the traveling salesman problem. We'll focus on these in greater detail in the next class, but let me just introduce the two problems. So a Hamiltonian circuit problem is this. Given a graph, what we want to find out is whether there's a tour on this graph. So we have to know what is a tour. A tour is a sequence of vertices such that you start from a start and end at the same vertex, and you have to go through the other vertices exactly once. So let us see. So there's a tour on this graph like this. You can start at A, go to B, and then to C, and then to F, and then to E, and then to D, and then to A. So you can start with A and come back at A. So that is a tour, and you go through all the other vertices exactly once. Okay. Now, is that the only tour in this graph? No. You can start with B, go through like this. In this, we can make use of this tour itself. You can go through from B to C, F, E, D, A, and then come back to B. That's also a tour. There could be some other combinations of intermediate vertices. There could also be a tour. So what we want is a decision problem, is an answer whether this graph has a tour or not. I don't want the actual tour. I want an yes or no answer, whether a given graph has a tour or not. So that is called the Hamiltonian circuit problem. Now on this graph, whatever you try, this graph does not have a tour, because you cannot start from one vertex, go around all the other vertices exactly once, and come back to the starting vertex. So the answer should be no. This graph does not have a tour. So that's the answer we want, yes or no. That's a Hamiltonian circuit problem. Okay, so that's a decision problem. Let me check. I think you're out of time. Alright, okay, so we'll stop here. So next class we'll look at traveling salesman problem and go through the rest of the module. Okay, so we'll stop with this. There is something, what is that, assignment due today, so go ahead and submit it. There's an exam due next week, so start working on that too. Okay, so if you have any questions, you can email me or message me. I'll also available from 3. You can ask me any questions. So we'll stop with this for today.